Here we have another definite integrals example problem, and in this video we're going to focus on the topic of continuity. So if we have a function that is continuous on a to b, then we can take the definite integral and we'll get f large capital F of x, and we can evaluate that at the boundary conditions of a to b. But what exactly does continuity and being a continuous function actually mean? So this is an easy visualization of a continuous function over a boundary a to b. So you can see here, I've just graphed a random function and we have our boundary a to b, and we can see that this function is continuous because there's no breaks or gaps along the line of the graph from our boundary a to b. And so we can look at some example problems just to see why it's important to make sure that your function is continuous along your boundary condition. So here we have the function y squared plus y to the negative 2 dy. And so we can graph this function, and you can see we have the graph here on the bottom. And when we look at our boundary conditions from 1 to 2, we can see that our function indicated in blue is continuous. We have no breaks or gaps along this line of the graph. But when we look at part B of our boundary conditions from -1 to 2, we can see that we're going to have a gap or a break at y is equal to 0. And so that is because we have this y to the negative 2 power. So we can't have y equals 0 because that will give us a division by 0 error. And you can see that illustrated in our graph. There is a break at the location y is equal to 0. And so when we evaluate this part B term, we can't. So this integral, we won't be able to evaluate this integral from these boundary conditions. And so this is just something to make sure that you think about, because although you can do this integration, this is a very simple and easy integration. We can get, 1/3 y to y cubed minus 1 over y. This is easy. But if you evaluate it at these boundary conditions, you won't actually be solving anything, and you'll just be thinking that you're solving a solution, but you won't get the correct answer. And that's because this function, part B, we're not able to do the integral. So this is just something to keep in mind when you're solving integrals, just to make sure that your boundary conditions are on a graph that is continuous.